This is the pre-lab video, so you should be making sure you watch this before the third day of this mole ratio lab. That's when we'll be doing all the calculations. So there are two parts to this. The first part is the net ionic equations for both copper 1 and copper 2. Okay, so both of them are going to start with copper and silver nitrate. For copper 1, when we switch copper and nitrate, oops, we get CuNO3. But if it's copper 2, we get CuNO3 too. And that's the only difference. We still have silver nitrate, we still have silver at the end. So this one requires us to balance. And that's how we're going to figure out which reaction actually happens once we do all the calculations, is by that mole ratio. So to write the net ionic equation, we'll keep Cu as a solid. And then over here, we'll separate these because nitrates, you know, are soluble. Then the nitrates will cancel out, and you'll get Cu plus Ag plus gives us Cu plus Ag. So one of the questions that I was getting in class last week is, why doesn't Cu cancel out with Cu plus? Okay, because one has no charge and one has a charge, so they are not the same exact thing. So this is our copper 1 net ionic equation. For copper 2, we're going to do the same thing, but now we have some coefficients to deal with because of that balancing. So this 2 gets distributed over each ion. And this time it's Cu2 plus. That subscript becomes a coefficient. Then our two NO3 minuses will cancel, and we'll get Cu plus 2Ag plus gives us Cu2 plus 2Ag. So that is our second option. So once we figure out all the calculations and the mole ratio, we can decide which of these two actually happens. So one of the things that I want to get you familiar with in this class is using Google Sheets or Excel to do our data calculations for labs. So I'm going to walk you through some basic calculations on Google Sheets today, and Excel, it will be the same. I did this a lot in college, and that was before computers were even as prevalent as they are now. So it's definitely a skill that you will use if you go into sort of any STEM fields. So the first thing I'm going to do is just list all the data I'm going to need. So you see I put data up at the top here, and then unit in column B, and value in column C. I suggest you do that same thing just because the commands are going to be based off the format of the table. So for right now, just do it the same. So then I listed all the different data or calculations we would do and the units next to them. Now you want to have a separate column for units when you do this, because if you put the unit with the number, you can't use the Google Sheet commands. Okay, so that's what you're doing there. So then I just made up data. Okay, this isn't anything. I just made up data for our lab. One thing I will say, the volume of silver nitrate, make sure you put it in liters. We measured it out in milliliters, but put it in liters. But the rest of this is all just made up. So the first calculation that I can do is moles of silver nitrate. Okay, we have the liters here, and we know the molarity is 0.1. So we would know that to find the moles, we would multiply molarity times liters. We can have Excel do that for us. So to start with Excel, you go into the cell, or Google Sheets, I should say. You go into the cell you want, hit equals, and then you're going to type the command you want. Now, there are a whole bunch of commands. We're just doing basic ones today. So we just said we would multiply. So you start writing multiply, and then click on the command. And then you can see it tells you to put the two numbers in that you want to multiply. So we know our molarity was 0.1, so I'm just going to type in 0.1, then put a comma, and then instead of having to type the number for the volume, since I already have it in my data table, I can just go up here and click on it, and then it shows up here. Then you close the parentheses, hit enter, and it does it for you. Ignore the suggested autofill. We'll do that in a minute. Okay, so that way, and this is going to be very helpful when you're doing calculations over and over again, because you don't have to type a bunch of stuff in. It will work out. So we'll see that in the future. So what you would do is multiply 0.1 times C3. So here I put that command. So the mass of the copper reacted is going to be the two masses. So the mass of copper at the start minus the mass at the end, because we know the rest of it reacted. So we're going to do equals. And then the command for subtraction is minus. So you keep writing that, and then you click it, and your parentheses will open. You're going to do value 1 and then value 2. So the mass of the wire at the start is C4, then do a comma and a space. And then the one we want to subtract is at the end. Close the parentheses and hit enter. Moles of Cu that reacted is going to be the mass that reacted divided by the molar mass of copper. So we'll do enter, divide, and then we're going to do the mass of copper that reacted. So we can just click that cell, comma, space, and then the molar mass of copper is 63.4. So you can go ahead and put that right here. And there's the moles. Next, we're going to do the experimental mole ratio. Now, again, your numbers are going to be very different here because I just made up this data. But for the experimental mole ratio, you would take the moles of AgNO3 over the moles of copper. So we're going to divide again. And then we want moles of AgNO3, which we found right here, comma, space, moles of copper. So that was C9. So then you close the parentheses and hit enter. So here, the experimental mass of silver, if you look on my little table here, I put Na because that's something you're going to mass out on day 3 in the lab. Okay, so for right now, I'll just put in a blank one there, but you'll be doing this in the next class. So I'm just going to say something. This one we're also going to leave blank right now. We have to figure out, in order to find the theoretical mass of silver, we have to figure out what the mole ratio is, and that's something we're going to do together in class. Okay, we're going to be taking this number and figuring that out together. What we are going to do is enter the percent yield. Now, we're going to have an error here, and I'm going to explain why that is in just a minute, but you might as well just put it in here and because we can enter that command. So percent yield is going to be the experimental mass, which is C11, over the theoretical mass, which is C12, times 100%. So the way you write that in Excel is you'll write equals and then multiply. So then your first thing is going to be, your first thing that you'll be multiplying is going to be that division. So the first thing we'll do is divide, and then we're going to divide C11, comma, space, C12. We're going to close that, and then for our multiplication, we're going to multiply whatever that division is by 100. Okay, so it will look like this. So that takes the division of actual over theoretical times 100. So when I hit enter, you're going to see error, and that's because our C12 right now is blank. Okay, so we have like a division in here that's 0. You know, you can't divide by 0. But once we have a number in there, which we're going to do tomorrow, like do in class, like let's say, I just made that up, you can see that it automatically puts it into our formula. So we'll do that in class together once we figure out what the reaction that we have is. Okay, and then you'll have this nice little handy thing that can do calculations for you.